Hey guys, hopefully my screen is visible. So I'm trying to explain what I understood about the topological sort. So we saw this course schedule problem, and in this course schedule problem, it's trying to it has given us a prerequisite. It has courses and it has prerequisites. So this in order to take this one, we need to complete, sorry, in order to complete zero, we need to take one. That's what it says, right? Yeah, for example, the pair 0 and 1 indicates that to take course 0, okay, yeah, it's other way around. To take course 1, here in this case, we have to take 0. Okay, and in this case, to take course 0, we have to take course 1. So topological sort deals with the um, in degree towards a node. So in DFS we were dealing with the out degrees, like how like a node, how many nodes are going out. So let's not digress from that. Let's stick to the topological sort. What topological? I haven't done this before. I'm not explaining. I haven't explained it to anyone, so I'm giving it short for the first time. So yeah. So basically, let's go here and go back. And if I go here, reload this. Hopefully, I can be able to see. Okay, so we have the screen in front of us, right? Um, Let me take a pen and draw some nodes. So this is let's copy the nodes from here. This is node 1, 2, then 3, then 4, and then 5, and then 6. So yeah, so this is how it's looking like. So what this indicates is, like, suppose you have to there was a nice video. So let's say you have to go to school. That video was explaining you have to go to school and you have to get dressed. So first of all, what you'll do is uh, you'll get up. So in order to get dressed, you'll first wear your underpants, and then you'll wear your shirt, then you'll wear your jeans, and then socks, and then shoes, and then you're ready to go to school. So yeah, in order to go to school, you need to perform these order of action, these action in certain orders. So here it's this directed graph. It's showing that in order to uh, go to 2, you need to perform 1. So so 2 has integrity, and then 2 has another prerequisite that in order to do 2, you have to do 3, and 3 has a prerequisite. In order to do 3, you have to do 5, and in order to do 5, you have to do 6. So here we can see 6, 4, and 1 doesn't have any prerequisites. So consider consider this graph as our courses. Um, this graph as our courses, and um, then we'll see. So what topological sort do is it maintains a graph, maintains an array. So in our question, the nodes will be always from 0 to n, 0 to n minus 1. So our array, we can simply define an array with the help of num courses is given to us, right? So num courses is 3, or so in this case, um, I'll renumber these. So I'll number these 0, 1, 2, 3, 4, 5. Okay. So let's say, yeah. So it's easier to understand. So we'll have this. Then everything will be 0 initially. So 0, 1, 2, 3, 4, and 5. So everything will be initially 0. And then we'll make an adjacency list according to the in degrees, in degree, like this guy. So for a prerequisite, for a given prerequisite, suppose this 0 is the prerequisite. So 0 is our prerequisite, right? So how many courses depend on 0? Here this array holds 1. Then we have to do it for every node. So 1, how many courses depend on 1? So it depends on 1. 3 is dependent, right? And how many courses are dependent on 2? So on 2, um, 3 is dependent, right? 3 is dependent, and sorry, 3 is dependent, and 4 is dependent. Okay. 4 is dependent, and then for 3, there is no dependency. There is wait a minute, I'm going somewhere wrong. So for 0, it's prerequisite for 1, right? So it has outgoing edge. For 1, 1 is prerequisite for 3, right? Yeah, so that's why it has an outgoing edge. So for 2, outgoing edge. So yeah, my bad. I went some here wrong. My bad. So here 1, outgoing edge defines it's which is dependent on that particular node. So on 2, 1 is dependent on 2. Unless and until you do 2, you cannot go. If you do 2, then only you can go to 1. So that's what it means. And is there any outgoing edge from 2? No. So just 1 is there, and then you can drop this extra thing off. And then 3. 3 outgoing edge is 2. So if once you are done with 3, then only you can do 2. Then we'll go to 4. Once you are done with 4, then only you can do 2. And then 5. Once you are done with 5, then only you can do 4. So 4 will come here. So this is our adjacency list. That's what we are creating here. Oh, I'm really sorry. I was okay. Yeah, I was doing this here. My bad. You guys were looking at some other screen, but yeah. Again, I'll repeat myself. So this outgoing edges defines that one is dependent on zero. So unless and until you have done zero, you cannot do go to one. And unless and until you have not done one, you cannot do three. And here, so this graph, this adjacency list is showing prerequisite and the dependent course. So here we can see if you do zero, you can do one. So one comes here. There is no other outgoing edge from zero. So one, what is outgoing edge here? Um, three. Three is so uh, after doing one, you can do three, and then in two, there's outgoing edge. Once you do two, you can do one, and then for three, there is outgoing edge. Once you do three, you can do two, and then for four, once you do four, you can do two, and for lastly five, once you have done five, then you can do four. So that's how we got the adjacency list. You can do use map or array for storing this adjacency list. Once you have done with this, then the next data structure that we will need is queue. So queue um, queue will hold all in degree which are equal to 0. Okay, equal to 0. So when as and when we are updating the adjacency list for 0, we are also updating the in degree. Here we have in degree array. So one has in degree of 1. This gets updated. 3 has 1. Then 2 has 1. There are 2 in degrees, so they will update this to 2. Here 1 is again showing up in degree. Then 2 have 2 incoming in degrees, as you can see here. So we'll update this to 2, and then 5 has in degree. Sorry, 4 has also have 1 in degree. So we'll update to 1. So in the end, we can see that 0 and 5 are the one which doesn't have in degrees. So we'll add these. So once we run a loop, so we will add in degrees which are 0, to the queue. So 0 and 5 are added to the queue. So then, okay, sorry. Then what we do is, once we have added, so here is the part where we are adding the queue, and then okay, so I'll just show it off here as we are in sync with this. So what we'll do is we'll create a while loop while q length is there. Um, then we are looping. Then we'll shift this um, and then we'll we'll check if it we'll check the neighbors, like the dependent on this particular node, and then if we check there is only one uh, there is only one node in the dependency array. So we'll decrement the dependency by one. So this will become one, and there is nothing else. So we come out of the loop, and this is gone. This is gone once we did it. Then we bring out this guy 5. Once we take out the 5, uh, then we have to uh, and we are constantly updating the number of visited nodes as and when we are visiting these. So currently our visited is one, 2 when we are visiting the 5. So if we check the 5 node dependency, then 4 is there. So we reduce the in degree of this. So it becomes 0. As soon as it becomes 0, we have to add that 4 here into the queue, and this is gone. So once we add 4, we have to again then pop, and then once we pop this, sorry, shift this, then this becomes 3, and we start checking for the node of dependency of 4, um, like what is dependent on 4. So 2 is dependent, so we reduce the 2 count by 1. So at this stage the queue becomes empty, and if you can see here, there is a cycle forming here. So we visited this, but we visited this, and after visiting this, we could not visit this part of the graph. So because of the cycle, and just because the cycle was there, uh, the number of visited nodes remain to 3. So uh, just so when we are returning, we have to just simply we are returning. We have to just check the number of visited visited nodes is equal to the number of courses that were given to us. So that's how you are able to figure out like whether all the courses can be done or not. If we see the code, so here we are creating the adjacency map. You can either use this or a map or an array to create this. Then in degree array, which is initially filled with 0. Then we set this up. Then uh, we create the adjacency list in order of the prerequisite in DF. I won't bring in DFS because DFS creates the adjacency list in reverse order, meaning it creates with respect to the courses and their prerequisite. Here we are having the prerequisite and the courses that are dependent on the prerequisite. So I hope that makes sense. So yeah, you can So yeah, this is adjacency list, get prerequisite, and in degree course. So here we are creating the course and then accordingly update the in degree for that particular course because it because we are creating an edge from the prerequisite to the course. So yeah, so the in degree for that course will increase. So we have to update it in the in degree array. Then we have the queue. Then we once we are done with all the prerequisites array given to us, we come here and then we loop through all the elements, all the values in the in degree and um, check for zero in degree. Then we come then once we push all those who have zero in the queue and then we check and then we loop through we loop like create a while loop and here we shift each node and visits its neighboring nodes and once we are visiting the neighboring nodes we are decrementing the value of the end degree as in like we have visited this node uh, like yeah, so once the degree of that particular node is zero we can um, push it to the in push it to the queue and then so on and lastly if number of nodes here also it's written that if we are unable to visit the cycle was unable to visit the cycle nodes. So if the number of visited nodes is less than the total number of nodes in the graph, we have a cycle. So number of visited nodes and the number of courses. So number of courses defines the number of nodes in a graph. Yeah, I had a difficult time to wrap my head around this n plus n. Like, yeah, we are definitely creating an adjacency list. Okay, it's m plus n. Okay, so and each key operation takes off one time. We are okay. Okay. I hope it was helpful. Um, I will try solving the course schedule too. So that would be the next step because it uses topological sort